The axial pump free problem. The propeller start pump of the previous, for example, video parts in previous section is closed in a duct and capture or approaches flow. In contrast, the free propeller for either aircraft and marine applications acts in an unbounded flow fluid, and this is much less effective. The analog of propeller pump pressure rise is the free propeller thrust per unit area. The analog of propeller pump pressure rise is the free propeller thrust per unit area. Swept out by the blade. In a customary dimensional analysis, thrust T and the power required P are functions of the fluid density. Thrust T and power, the function of fluid density, rotation rate, forward velocity, for example V, and the propeller diameter, speed, forward velocity, and the propeller diameter. Viscosity effects are small and neglected. You may enjoy analyzing this as the previous chapters. If the NACA choose as repeating variables and the results are the accepted parameters as CT, a non-dimensional for the thrust capacity, thrust coefficient, T on rho n square D4. Let me write in the next page. CT thrust rho into D4, a function of J. J is advance ratio, V on ND advance ratio, and the next is CP power coefficient, P on rho entry D5. It's also a function of J, and efficiency VT on P, JCT on CP. The advance ratio J, which compared forward velocity to a measure proportional to blade tip speed, has a strong effect upon thrust and torque. J is compare forward velocity to a measure proportional to blade tip speed. Has a strong effect upon thrust and power. This figure shows performance data for a propeller used on the Cessna 172 aircraft. Example of the propeller of a Cessna aircraft. The thrust and power coefficient are small and are multiplied by 10 as shown. The maximum efficiency eta max at where the C at the base efficiency point and the CP star for this case of the problem. There are also some computational fluid dynamics calculation for turbomachinery. The next section is matching pump to the system characteristics